Satellites work by using a combination of physics, engineering, and technology to orbit the Earth or other celestial bodies. Here's a simplified explanation of how they work. 1. Launching a satellite. Rocket launch. Satellites are launched into space using rockets. These rockets provide the necessary speed and force to overcome Earth's gravity and reach a stable orbit. Orbit insertion. Once the rocket reaches space, the satellite is released into a specific orbit, which is a path it will follow around the Earth or another celestial body. 2. Types of orbits. Satellites can be in different types of orbits, depending on their purpose. Low Earth orbit, LEO close to Earth, 200 to 2,000 kilometers above the surface. Used by satellites for communication, Earth observation, and space stations, like the ISS. Geostationary orbit. GEO 35,786 kilometers above Earth, where satellites appear to stay over the same spot on the Earth's surface. This is used for communication, weather monitoring, and television broadcasting. Medium Earth orbit, MEO between LEO and GEO, typically used for navigation satellites like GPS. 3. How satellites stay in orbit. Inertia. Once in orbit, satellites are constantly moving forward at a very high speed, around 28,000 kilometers per hour for satellites in LEO. This speed causes them to fall toward the Earth, but because they are moving so fast, they continuously miss the Earth, staying in orbit instead of crashing down. Gravitational pull. The Earth's gravity keeps the satellite in orbit, pulling it towards the planet, while the satellite's forward motion keeps it from falling to Earth. 4. Satellite systems. Satellites are made up of several systems that allow them to perform their functions. Power supply. Most satellites use solar panels to collect sunlight and convert it into electricity to power their systems. Some may also have batteries for backup. Communication. Satellites use radio signals to communicate with Earth. These signals are transmitted via antennas on the satellite and ground stations on Earth. Sensors and instruments. Depending on the satellite's mission, it may have cameras, radar systems, temperature sensors, and other instruments to collect data. For example, weather satellites use sensors to monitor clouds and storms, while GPS satellites help with navigation by providing location data. 5. Data transmission. Sending data to Earth. Satellites send data back to Earth using radio waves. The signal is received by ground stations, which then process and distribute the data. For example, weather satellites send images of cloud patterns, and communication satellites relay TV signals. Receiving data from Earth. Some satellites can also receive commands or updates from Earth to adjust their position, fix a malfunction, or change their function. 6. Satellite communication. Transponders. Communication satellites carry devices called transponders, which receive, amplify, and transmit signals back to Earth. These are used for things like phone calls, TV broadcasts, and internet access. Tracking and control. Ground control stations monitor the satellite's position, speed, and health to ensure it stays on course and functions correctly. 7. End of life. Deorbiting. Over time, satellites may lose their functionality or fuel. Some are designed to burn up upon re-entry into Earth's atmosphere, while others are moved to a graveyard orbit in the case of geostationary satellites. Space debris. Satellites that are no longer operational contribute to space debris, which is a growing concern for future space exploration and satellite launches. In summary, satellites work by being launched into space and staying in orbit around Earth, using their systems to communicate, collect data, or provide services like navigation or weather monitoring. Their operation relies on the balance between gravity and their high-speed motion, as well as advanced technologies on board. The silent Sentinel. Far beyond the bustling cities and bright lights of Earth, in the depths of space, there was a satellite unlike any other. It was called Sentinel-9, and it had been launched many years ago, a quiet guardian circling the planet with a mission that no one fully understood. Unlike typical satellites that transmitted signals or gathered data for communication, weather, or military use, Sentinel-9 had been built with a secretive purpose in mind, a purpose lost to time and memory. Its original creators were long gone, leaving behind only cryptic records about its task. All the world knew was that it had been designed to observe, not just the Earth, but something far beyond it. The satellite had been programmed to look into the empty expanse of the universe, to search for signs of something not yet discovered. It wasn't searching for planets or stars, but rather something that couldn't be detected with human eyes. A presence that lurked between the stars, a mystery wrapped in the silence of space. Years passed, and the world moved on. New satellites launched, technology evolved, but Sentinel-9 continued its mission, its metallic frame silently drifting through the void. No one checked on it. No one thought about it. It became just another forgotten piece of space junk, orbiting endlessly in a silent, lonely dance. But then, one day, as its sensors scanned the darkness, Sentinel-9 detected something strange. A signal, a subtle shift in the background radiation, a blip that had been so faint it would have gone unnoticed by any other satellite. It wasn't a communication from another civilization, nor was it an anomaly of space. It was something older, ancient, hidden within the fabric of time itself. The satellite sent the signal back to Earth, its data transmitted to a forgotten research facility, now abandoned and closed. But it wasn't just data. It was a message that had been buried in the stars for centuries, waiting to be found. The message was clear, but the meaning was not. It was a riddle, encrypted and hidden in the patterns of the signal. It spoke of a distant galaxy, where time folded in on itself and light did not travel in straight lines. A place where sentinels like Sentinel-9 were not solitary, but part of a greater network designed to guard the universe against an ancient force, an entity so vast it had been erased from all known records, its very existence a myth. The data was